Hello guys, welcome to RS Code Labs. Today we are discussing about identifiers in Java. Identifiers are the names used to identify variables, methods, classes, packages and interfaces. Yes, which means identifiers are the naming words used for identification purpose. While writing identifiers, we should follow some rules. Okay? Identifiers allows characters. Identifiers can contain letters, digits, underscore and dollar sign. For example, here we are declare a variable is it allows characters whether it is uppercase or lowercase, so this one is valid, and it allows underscore as well, so this one is also valid. And next one is it can't start with a digit. Okay, identifiers must not start with a digit. For example, here int 1 number, it start with digit, so it is invalid. Int number 1, it doesn't start with digit, so this one is valid. And one more rule is it can't be a Java keyword. Java reserved keywords like class, int, new, etc. can't be used as identifiers, so it doesn't allow keywords. Okay, for example, int class, this one is invalid. Why? Because class is a keyword. Int my class, this one is not, this one is valid because it is not a keyword. Why special characters are not allowed in Java identifiers is special characters are not allowed except dollar and underscore. Okay, in Java identifiers must follow certain rules. One of these rules states that special characters except dollar and underscore are not allowed in identifiers. Here's why. One is to maintain code readability and simplicity, and to avoid confusion with operators, to prevent conflicts with Java syntax. Now we will discuss about data types. Data types specify the kind of data that a variable can hold. Java is a strongly typed language, which means that every variable must have a predefined type. Yes, data types are mainly used to define what type of data we are going to store. And in Java, data types are divided into two types. One is primitive data type and other one is non-primitive data type. Primitive data types are divided into three types. One is numbers, character and Boolean. Numbers again divided into two types, integers and floating point. Again, integers are divided into four types, byte, short, int, long. And floating point is divided into two types, double and float. And characters, in Java, character literally should be write within single quotes. To store character value, we are using char data type. Boolean is used to store true or false values. Here byte value. Here byte. Byte is one of the integer data types. Size of the byte is 1 and range in between -128 to 127. Sorry. And default value of byte is 0. And next one is short. Size is 2 bytes. Range in between this value. And default value of short is 0. Int. Int size is 4 bytes. Range in between this value. And default value of int is 0. Long. Size is 8 bytes. And range in between this value. Default value of long is 0L. And next one is floating point. Size of the float is 4 bytes. Range approximately this value. Range in between this value and default value is 0.0f. And next one is double. Size 8 bytes. Range in between this value and default value of double is 0.0d. Character. In Java, character literal should be write within single quotes. Here you can see we can write the character in between the single quote. To store character value, we are using char data type. Here you can see. Okay, size is 2 bytes, range in between this one and default value is this. Boolean. Size is 1 bit, values true or false and default value is false. Coming to non-primitive data type, non-primitive data types do not store values directly but it holds references to object in memory. One is string data type. It is used to store sequence of characters. See, string name equals to, within the double quotes we are writing the string. Okay, anything which we are written in double quotes, that is nothing but a string literal. Array data types. It stores multiple values of a same type in a single variable. Here you can see multiple values we are storing in single variable. Class is a blueprint of an object. Inside the class we are creating variables and methods. Literals in Java. Literals in Java are constant values that are directly assigned to variables. These values do not change during program execution. For example, int a is equals to 25. 25 is a literal. Char grade equals to a. A is a literal. Boolean is Java fun equals to true. True is a literal. Types of literals in Java. There are 5 types of literals: integer literal, floating point literal, character literals, and string literal and Boolean literal. Integer literal. It represents whole numbers and can be expressed in different formats. Here you can see these are all examples for integer literals. And float point literal. It It represents decimal numbers and can be of two types. For example, float pi equals to 3.14f is one. If you are using float data type, f is required for float. If you are not specifying the f here, you may get error. Double price equals to 19.99. No need to require for D. Okay. Character literal. It represents a single character enclosed in single quotes, which means character literals should be right within single quotes. Here you can see these are all examples for character literal. String literal. Here, when anything which are written in double quotes, that is nothing but string literal. Here you can see this is the example for string literal. And Boolean literal represents only two values. One is true and next one is false. These are all examples for Boolean literal. Now we will discuss about variables in Java. A variable is a named memory location that stores a value, and the value of a variable can change during program execution. Here, for example, int a is equals to 25. Int a is equals to 25. Here, age is a variable. It's storing a value as 25. Okay. Types of variables in Java: local variable, instance variable, and last one is static variable. Okay. Local variable, which means any variable which we are declared directly inside a method or a constructor or any block except class block is known as local variable. Here you can see this is the local variable. Why? Because this variable we are declare, and one more rule in local variable is you must initialize the variable. If not, you may get error. And next one is instance variable. Instance variable declared inside a class but outside any method. Each object gets its own copy of instance variable. Okay, default values if not initialized, Java assign default value as 0. For example, here you can see these two are instance variables. While you want to call these variables, if you want to call these variables, you have to create an object. Through the object reference, you call these variables. Okay. Static variable. Static variable declared within the static keyword inside a class. It shares across all objects. No need to create an object in static variable. You can call directly by using class name. It can be allocated the memory at class loading time. Here you can see this is a static variable. Here you can declare a variable with the help of static keyword. And you can call that variable directly without any creation of object. What are operators in Java? Operators in Java are symbols used to perform operations on variables and values, which means operator is a predefined symbol. It is used to perform a specific task on given operands. Operand is nothing but it is a value on which the operator will be executed. Okay. Here you can see the example. Int a equals to 10 and b equals to 5. Here we are adding both the values with the help of plus operator. So the output it returns 15. Here you can see types of operators in Java: arithmetic, relational, logical, bitwise, assignment, unary, ternary, and instance of operator. Now we will discuss each and every type in detail. Okay, arithmetic operator. This arithmetic operator performs mathematical calculations like addition, subtraction, multiplication, and etc. Here you can see this plus operator is used to add the values, and subtraction is used to subtract the values. Multiplication is used to multiplicating the two values, and this division is used to divide the values, and also this modulus symbol is used to get the remainder of the two values. Here you can see the example of arithmetic operation. And next one is relational operation, which is used to compare the values and return true or false. Okay, here you can see double equals to is used to comparing the two values. If it is true, it returns true. Here you can see 10, a value is 10, b value is 5. Both the values are not same, so it returns false. It is also comparing the values. Here you can see a value not equals to b, as it is true. Why? Because a value is 10 and b value is 5, so it returns true. A greater than b, as it is true. Here you can see a value is less than b, this one is false. Here you can see a greater than or equals to b, this one is true. Here you can see the condition a less than or equals to b, this one is false. Here you can see the example of relational operator. Logical operator, it is used to check more than one condition. Logical AND returns true when all the conditions are true. In case of logical AND, if the first condition is true, then only it will check for next condition. Okay. While using the AND operator, both the values should be true. Otherwise, it will returns the result as false. Coming to OR operator, first in case of logical OR operator, if the first condition is false, then only it will check for next condition. It will return true when any one of the condition is true. Coming to not, logical not will return true when the condition is false. Okay, this is the example for logical operator. And next one is bitwise operator. This operator works at the bit level. Here you can see the operators AND, OR, XOR, complement, and left shift and right shift. Here you can see the examples and result. Okay, this is the example for bitwise operator. And next one is assignment operator. Assignment operator is used to assign values to the variables. These are all assignment operators. These are all used to update the value and assign the value. Here you can see the example of assignment operator. Unary operator. This operator works on a single operand. These are all unary operators, and you can see the result based on the example. Okay. And next one is increment operator and decrement operator. Increment operator adds 1 to the variable. Again, it has two types: pre-increment and post-increment. Pre-increment, it increases the value before use, and post-increment, it increases the value after use. Decrement operator, it decreases or it subtracts 1 from a variable. It has again two types: pre-decrement and post-decrement. It decreases the pre-decrement, it decreases the value before use, and post-decrement, it decreases the value after use. Here you can see the example of the increment and decrement operator. Ternary operator. Ternary operator is also known as conditional operator. Conditional operator, it is used to check the conditions. This is the shortcut for if else. Syntax of ternary operator, it checks the condition. If the condition is true, statement 1 is executed. If the condition is false, statement 2 is executed. This is the example for conditional operator. Now we will discuss about conditional statements in Java. Conditional statements allows a program to make decisions based on a certain conditions. These statements control the flow of execution by executing specific blocks of code depending on whether a condition is true or false. Types of conditional statements in Java: if statement, if else if, switch, ternary operator. If statement, if it executes a block of code only if the condition is true. This is the syntax of if statement. This is the example of if statement. Here you can see if the condition is true, then only the statement will be executed. If the condition is false, it will skip. If else if, it executes one block if condition is true, another if false. This is the syntax for if else statement. Here it is the example. Here you can see if the condition is true, if block will be executed. If the condition is false, else block will be executed. Here you can see the condition is false, so else block will be executed here. If else if ladder. It is used to check multiple conditions sequentially. Syntax of if else if ladder. Here you can see in if else case, first the condition will be checked. If the condition is true, then the statements which is present inside the if block will get executed. If the condition is false, then the statements which is present inside else block will get executed, and the execution will continue. Okay. Switch statement. It is used to check multiple values instead of conditions. Works with int, char, string, and enum. Syntax of switch. An example. First the switch condition will be executed, later it will compare with all the case conditions. Okay. While checking the case condition, if any case condition is matched with switch condition, then the particular case block will get executed and the execution will continue. While checking the case condition, if any case condition matched and if you want only the particular case block to be executed, we can use break. Now we will discuss about loops in Java. Loops are used to execute block of code multiple times. Java provides three types of loops: for loop, while loop, and do while loop. For loop is used to when the number of iterations is known beforehand. This is the syntax for loop. This is the example for loop. It iterates 5 times. Why? Because here we are giving the condition I less than or equals to 5. So I value can be iterated 5 times. While loop, it is used when the number of iterations is not known in advance. This is the syntax for while loop and example code for while loop. Here you can see, here we are giving the condition I less than or equals to 5, and here we are printing the I value and we are incrementing the value. It checks the condition. First, initially I value is 1, so first it prints the 1, and again I value incremented by 1, so I value changes to 2. 2 less than or equals to 5, condition is true, so again it prints the I value is 2. Again, and next step is I value incremented by 1. So I value incremented by 1. So I value becomes 3. Again, it checks the condition 3 less than or equals to 5. Yes, condition is true. So I value will be printed. Again, updated the value as 4. I value, it can be iterated until and unless the condition becomes false. Do while. It is similar to while loop, but it ensures that the loop body execute at least once. This is the syntax for do while loop. An example of do while loop. Jump statements. Jump statements controls the flow of loops and switch cases in Java. Java provides three jump statements: break, continue, and return. As break statement, this is used to exit a loop. Here you can see the example of break. Here it can check the condition. If the condition is true, it terminates the loop when I equals to 3. Okay. Continue statement, it skips the current iteration and moves to the next iteration of the loop. Here it checks the condition. When I value becomes 3, that iteration can be skipped and continued for the next iteration. So output it returns 1, 2, 4, 5. And next value and next statement is return statement. It is used to exit. It is used to exit from your method. Return statement is used to exit from your method. Here you are using return statement. So the output of the program is before return statement. An array is a collection of elements of a same type stored in contiguous memory location, and it allows us to store multiple values in a single variable, which means array is a continuous block of memory. It is used to store multiple values of same type. Here you can see there are two types of arrays in Java. One is single dimensional array and other one is multi-dimensional array. Single dimensional array. One dimensional array is a simple list of elements of the same type. Here you have 1D array. Here you can see num is the variable and 2, 6, 3, 9, 7, 0. These are all elements. And 0, 1, 2, 3, 4, 5, these are all indexes. If you want to accessing these values with the help of index array, index value always starts with 0. Here you can see we can declare an array in two ways. One is data type array variable name, and next one is data type variable name array. And also we can declare the size of an array. Here you can give the size of an array. It stores the 5 integer values. If you want to assign the value to the variable, you can assign this way. And if you want to assign all the variables in one line, then you can choose this way. Here you can see we can declare and initializing the values in one line. Here you can see class name is array example, and inside the main block here we can declare an array, and here we are initializing an array with size 5, and we are assigning values to the variable. If you want to assign all the values in one line, then you can choose this one. And also we can accessing the elements with the help of index value. Here you can see we are printing numbers of 0, so it prints the value at 0th position. Here you can see index value 0, 10 is there, so it returns 10. Numbers of 1, index value 1, at index value 1 value is 20, so it returns 20. If you want to change the value at specified index, you need to specify the index value and you need to update the value at the specified index. So here it prints the updated value instead of printing the values like index 0, 1, 2, so on. So can also print all the values from an array by simply wrapping them in a loop, and you can iterate through each and every value array in that loop. So you need to create one variable which will loop into a array. So here I create a variable as I. Let's say I equals to 0, right? I less than or equals to, here we are giving the size of an array. Based on the size, it will iterate the loop, and here we are incrementing the I value. Here numbers dot length, so it represents the size of your array. Here you can see the size 1, 2, 3, 4, 5. Here size is 5, right? I less than 5, so basically 5 times you have iterate the loop. Okay, so for every iteration I have to increment I value by 1. So initially I value is 0. Here it checks the condition I less the I value. It prints the I value. Initially I value is 0. So numbers of I value is 0, right? Numbers of 0. So first it prints the 10 value. And again I value increment by 1. So I value becomes 2. Sorry, I value becomes 1. So again it checks the condition less than or equals to 5. Yes, condition is true. So it prints the numbers of 1. So it prints the output 20. Then it prints the value as 20. Again I value increment by 1. So it becomes 2. So I value is 2. 2 less than or equals to 5. Condition true, it prints the statement. Again I value, and again it prints until if the condition becomes false, then only it will stop the printing statement. Until and unless. Here I value is 4. Again it checks the condition 4 less than 5. Condition is true. So it prints the statement. Again I value increment by 1. So I value becomes 5. Again it checks the condition. Condition not satisfied. So it stops the execution. Execute the code. Here you can see we can print all the elements in one line with the help of loop. Next one is multi-dimensional array. It is also known as 2D array. A multi-dimensional array is arrays of array. It is the structure of 2D array. And here you can see we can declare and initializing an array. It represents the row of an array, and it represents the column of an array. We can access elements in 2D array with the help of two indices. Here you can see the example. Here we are declare and initializing an array, and yeah, if you want to print the 6 value, then you need to mention the row value and the column value. Here you can see row 1 column 2 6 is present. If you want to print 6, you need to print row 1 and column 2. If you want 7, you need to print row 2 and column 0. Yeah. Example for 2D array. Here we are declaring and initializing an array. The array is in the form of matrix structure. Here we are accessing and printing the specific elements at row 1 and column 2, which means it has row 1 4 5 6 and column 2 in row 1, which means the element is 6, so it returns 6 value. Next printing statement is row 1 and column 1, which means this is the row 1 and this is the column 1, so the output 5 it returns. Let us execute the code. Here you can see first printing statement output is 6 and next one is output it returns 5. Okay. First, let us understand the definition of string. String is a collection of or group of characters that can be stored in a specific order. String is a non-primitive data type. String can be a literal or object in Java. String literal is nothing but anything which are written in double quotes is known as string literal. And strings are represented as objects of the string class. That is nothing but strings in Java. Strings are created using the string class, which provides many useful features to work with text, and they are widely used to storing and manipulating the text. That is nothing but strings are commonly used to store words, sentences, and other type of text data. String objects are immutable. Yes, in Java, strings are immutable. Once the string object is created, its value cannot be changed. In Java, strings are creating two ways, using string literal and using the new keyword. Using string literal, we are assigning literal to the variable. In using the new keyword, we are creating an object for a string class and pass the value to it. What is the string pool in Java? The string pool is also known as string constant pool. It is a special part of the heap memory, where Java stores string literal to save memory, and also it improves the efficiency. Let us see how it works. When a string literal is created, Java checks if it already exists in the string pool. That means whenever we declare a string directly, first it will check the string literal is present or not. If the string literal is present, that means if it exists inside the string constant pool, instead of creating a new object, it will copy the existing reference. If the string literal is not present inside a string constant pool, that means if it does not exist, then only it will create a new object. Okay. Example for string constant pool behavior. Here we are assigning literal to the variable s1, and here we are assigning literal to the variable s2. Here these two literals can be stored in string constant pool. We are in this string s3 equals to new string of, we are passing the literal. That means we are creating an object for the string class and pass the value to it. Here it creates an object in heap memory. Here we are writing two printing statements, s1 and s1 double equals to s2, and then s1 is s1 double equals to s3. Here double equals to is used to comparing the references of an object. S1 and S2 references are same. That's the reason the output is true. Here S1 and S3 memory locations are different. That's the reason the output is false. Why we use the string pool? Why? Because it saves the memory by reusing the string objects, and also it improves the performance or speed by avoiding the duplicates. Before going to discuss about string buffer and string builder, we are discuss about characteristics of string class. In Java, string is immutable in nature. Whenever we are trying to modifying the existing string literal, it will create a new object instead of modifying the existing object. To avoid this disadvantage of strings, we are going for string buffer and string builder. Here, string buffer and string builder are mutable. String buffer is mutable. It can be changed without creating a new object. And it is thread safe. That means it is safe for multiple threads, allowing them to modify without issues. It is slower compared to string builder because of synchronization. Example for string buffer. We are creating an object for string buffer with the initial value as hello and appending the val to the same string buffer object. Here it prints the hello world. Updated value as hello world. Now we will discuss about string builder. String builder. It is mutable and faster. String builder is similar to string buffer, but it is not synchronized and it is not thread safe. And it is faster than string buffer for single thread operations. And we prefer when the working with string is not multiple environments. That means best for single threaded programs where multiple threads are not modified the string. Example for string builder. Here we are creating an object for string builder with the initial value as hello, and we are appending the val to the same buffer object. Here it prints the updated value as hello world. Stands for object oriented programming system or object oriented programming software. Object-oriented programming is used to convert real-world scenarios into software. In object-oriented programming, we can write programs with the help of classes and objects, and it helps in organizing and structuring the code for reusability, modularity, and scalability. Now we will discuss about class. Class is nothing but it is a blueprint of an object because it consists of properties and behavior. It is mainly used for two purposes: used to execute a program, and other one is used to provide a blueprint of an object. Now we will discuss about object. Object is nothing but it is a real world entity. It has some properties and behavior. Here for example, human is an object. Now it has some properties and behavior. Properties are name, age, color, height. These are all properties. Speak, eat, walk, stand. These are all behaviors. Now we will discuss about methods in Java. In Java, a method is a block of code to perform a specific task. Methods helps in code reusability and modularity. Syntax of method: access modifier, return type, method name, and formal arguments. Now we will discuss each and every word of the syntax. Access modifier in Java. Access modifier is used to define accessibility or visibility of the method. Modifier in Java, we have two types of modifiers. One is static and other one is non-static. Return type. Return type is mainly used to define which type of data the method is going to return. And last one is method name. Method name is similar to an identifier which is used to identification purpose. These two are formal arguments. This is method of the body. It consists of set of instructions to perform a specific task. There are two types of methods in Java. One is predefined method and other one is user-defined method. Predefined methods: any method which is already defined or developed by the some people is known as predefined method. User-defined method: any method which is defined by the programmer or user is known as user-defined method. Again, user-defined method is divided into two types. One is based on modifiers and other one is based on arguments or parameters. Coming to based on modifiers, again it has divided into two types. One is static method and other one is non-static method. Based on arguments or parameter, again it has divided into two types. One is method without parameters and other one is method with parameters. Method without parameters, which means a method which does not contain any type of parameter or argument, is known as method without parameter. Method with parameter means a method which consists of at least one argument is known as parameterized method or method with parameters. Method using a value, which means we can return a value from the called method once after executing all the instructions which is present inside called method. Syntax: return type, method name, we are passing the parameter. Here we can return a value by using return statement. Now we will discuss about method overloading. In Java, method overloading allows multiple methods to have the same name but different types of parameters in the same class. Compiler differentiates them based on the number of the parameters. Example for method overloading based on the length of the arguments. So we are defining a class name is addition, and we are defining a one method public static int add, and we are passing two parameters. Public is an access modifier, static is a modifier, and int is the return type, add is nothing but method name. Here it returns a plus b, which means it returns the sum of two numbers. Again we are defining method with three parameters and also it returns a plus b plus c, which means it returns the sum of three numbers. Coming to main method, public static void main method, which means program execution starts here. Okay. So here we are calling the add method with two arguments, add 5, 10. These two values can be stored in one variable. Here we are printing sum of two numbers. So it returns output as 15. Again we are calling the method with three arguments. This can be stored in one variable. So here we are printing the sum of three numbers. So it returns the output as 30. Now we will discuss about constructors in Java. A constructor is a special non-static member which is used to create an object and initializing the properties of an object. Syntax of constructor and some of the key points of constructors. Here constructor name and class name should be same. There is no return type in constructor. Whenever we are creating an object, constructor will get executed, and if no constructor is defined, Java provides a default constructor. There are two types of constructors in Java. One is default constructor and other one is parameterized constructor. Default constructor is also known as compiler defined constructor. Compiler will add default constructor when the programmer fails to add any constructor to the program. A constructor without parameters, Java provides a default constructor if no constructor is defined. Example for default constructor: here class name is student. Compiler will add a default constructor with no arguments. Whenever you are creating an object, constructor gets called automatically. Parameterized constructor. Parameterized constructor, which means a constructor which consists at least one formal argument, is known as parameterized constructor. The arguments which we declared in the constructor header is considered as local variables of the constructor. Okay. Example for parameterized constructor. Here we are defining a class name is student, and we are declaring a variables string name and int is. String name, it stores the string name, it stores the name of the student. Int age, it stores the age of the student. Now we are creating a parameterized constructor, which means public student string n comma int a. Here name equals to n, which means assign the passed value n to the instance variable name, and age equals to a. Assign the passed value a to the instance variable age. Now we are create a method to display the student details. Coming to main method, inside main method we are creating an object of student and pass the values to it to the constructor and pass the values to the constructor. Now call the display method to print the student details. So it returns the output as name as John and age as 20. Today we are discussing about polymorphism in Java. Polymorphism means many forms and allows methods to perform different tasks based on the object calling them. So which means polymorphism is the ability of an object to exhibit multiple forms or behaviors. In Java, polymorphism are divided into two types. One is compile-time polymorphism and other one is runtime polymorphism. Coming to compile-time polymorphism is also known as static polymorphism, which means if the binding is achieved from method calling statement to method implementation statement during the compile time is known as compile time polymorphism. We can achieve compile time polymorphism with the help of method overloading. As we know, method overloading means a class can have more than one method with same name but different in arguments or parameter. So example for method overloading. Here we are defining a class name is math operations, and we are defined method with two parameters, and again we are defined method with three parameters inside the main method, which means program execution starts here. Here we are calling the add method with two arguments, which means that this method calls method with two arguments, which means this one. Again we are calling the add method with three arguments, which means it calls the method with three arguments. Here you can see binding is achieved from method calling statement to method implementation statement. So this is the best example for compile time polymorphism. Coming to runtime polymorphism is also known as dynamic polymorphism, which means if the binding is achieved from method calling statement to method implementation during the runtime is known as dynamic polymorphism. We can achieve runtime polymorphism with the help of method overriding. Method overriding means it allows subclass to provide a specific implementation of a method that is already defined in the parent class, which means superclass and subclass having same method signature but subclass have different implementation. Example for method overriding. Here we are creating a parent class name is animal, and we are defining a method void make sound. We are implementing a printing statement animals makes a sound. And here we are defining a class name is animal, and we are defining a method void make sound. Here we are implementing a statement as animals make a sound, and again we are defining a child class which extends the parent class. Here it overriding the make sound method from the animal class. Here you can see child class that overrides the make sound method. So overriding means subclass and superclass having same method signature but different in method implementation. Here you can see implementation should be different. Coming to main method, which means the execution starts here. Here we are creating an object of dog class and calling the overridden method dog.makeSound, which means it calls the dog's make sound method. So it returns the output as dog barks. Now we will discuss about four main Java OOPS principles. One is encapsulation, abstraction, inheritance, and last one is polymorphism. Now we will discuss about encapsulation. Encapsulation is the process of combining data members and function members into a single unit. Advantages of encapsulation is data hiding. Data hiding, which means the process of restricting the direct access of your data members and providing indirect access through the function members. We can achieve data hiding in Java. You have to follow few steps. First, declare a variable as private and provide the getter and setter methods. And also we can achieve encapsulation with the help of class, because class is having both data members and function members. Example for encapsulation in Java. Here we define say pen class and we are declaring a private variables string name and string color. The name and color variables are private, which preventing the direct access. Now we are creating a constructor which initialize the values when a pen object is created. Now we define a getter method and setter method. Getter method is used to read the data and setter method is used to update the data. Getter method returns the value of name and color, and setter method is used to update the value of name and colors. Now coming to main method. Inside the main method we are creating an object of pen class. Here creates a pen object p with initial values. Here we are printing the initial values. It calls a getter method to display the initial values and update the values using the setter method. So again updates the name and color using the setter methods. Again it prints the updated values. Here it calls again the getter method to display the updated values. So the output is like Parker, pen name is like Parker and pen color is black. Today we are discussing about inheritance in Java. Inheritance allows a class to acquire properties and methods from another class, which means it is the process of acquiring properties and behavior from parent class to child class. Here parent class means which gives properties and behaviors to other class is known as parent class. Parent class is also known as superclass. Child class means which takes properties and behavior from parent class. It is also known as subclass. And the main advantage of inheritance is code reusability, and it improves the readability and maintainability of the code, and method overriding. Extends keyword is used to inherit a class. Okay. Types of inheritance in Java: single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, and hybrid inheritance. Note: Java does not support multiple inheritance with classes to avoid ambiguity. It is only achieved through interfaces. Okay. Single inheritance. A child class inherits from a single parent class, which means the process of acquiring properties and behavior from one parent class to one child class. Here, inheritance is in single level, so it is single level inheritance. Now we define a superclass. Class name is animal, and we create a method. Method name is eat, and implementing this method. Again, we are defining a child class which inherits a parent class with the help of extends keyword. As we discussed, we can achieve inheritance with the help of extends keyword. Again, we are defining a method and we are implementing this method. Inside the main method, we are creating an object of dog class. So here we are call the eat method, which is inherited from the animal class. It is inherited from the animal class. Again, so since dog extends animal class, it can use this method without redefining it. Okay. Dog.bark method. It calls the bark method, which is defined in the dog class itself. So the output it returns: this animal eats food and dogs barks. Multi-level inheritance. A child class inherits from a parent class and another class inherits from the child class. This forms a chain of inheritance, which means a superclass having multiple subclasses in multi-level is known as multi-level inheritance. In multi-level inheritance, superclass will give properties and behavior to one subclass. Okay. And again subclass gives properties and behavior to another subclass. In multi-level inheritance, first subclass acts like superclass as well as subclass. Here, example for multi-level inheritance. Here we are creating a superclass. Class name is anyone, and we are defining a method. We are implementing this method. Again, we are creating a subclass. Class name is dog, and we are inheriting the parent class. Okay. Again, we are defining a method. Method name is bark. We are implementing this method. Again, we are creating a subclass. Class name is puppy, which inherits the parent class. Again, we are defining a method and implementing the method inside the main method, which means it executes the code of the program. Here we are creating an object for subclass puppy.eat. It calls the eat method, which is inherited from the animal class. Puppy.bark. It calls the bark method, which is inherited from the dog class. Puppy.weep. It calls the weep method, which is defined in the puppy class itself, So the output it returns: this animal eats food. And dogs barks, and puppy weeps. Hierarchical inheritance. Multiple child classes inherit from a single parent class, which means it is the process of acquiring properties and behavior from one parent class to multiple child classes. and all the multiple child classes should be present in same level. So it is known as hierarchical inheritance. Example for hierarchical inheritance. Here we are creating a parent class. Class name is animal, and we are defining a method eat. We are implementing this method. Again, we are creating a subclass. Class name is dog, which inherits from the parent class, and we define a method bark, which is implemented. And again, we are creating a one more subclass which is inherited from the parent class. And again, we define a method meow. And again, we are implementing this method. So coming to the main method, which means it starts the execution of the program. Okay. Here we are creating an object for dog class, and here we can call eat method, which is inherited from the animal class. And again, we are called bark method, which is defined in the dog class itself. Again, we are creating an object for cat class. Here we are calling the eat method, which is inherited in the animal class. Again, we are called the meow method, which is defined in the cat class itself. Okay. And here you can observe dog and cat are separate child classes of animal. So both inherit the eat method from the animal. Each child class has its own unique method. One for bark for dog and other one is meow for cat. Okay. So it returns the output like this. Multiple inheritance in Java. Multiple inheritance means a class inherit from more than one parent class, which means acquiring properties and behavior from multiple superclass to single subclass. Java does not support multiple inheritance with class to avoid ambiguity problems. However, Java allows multiple inheritance using interfaces. Example for multiple inheritance. Here we are creating a class A and defining a method A. We are implementing this method. And again, we are creating a class B and we are defining a method B along with implementation. Here, class C extends class A and B. So, class C extends both A as well as class B. Therefore, it has two immediate superclasses. Okay, since class C has two immediate superclasses, there will be a confusion to call which superclass constructor first. This is known as ambiguity problem, which is nothing but diamond problem. So, it will throw an compile time error. And the next one is hybrid inheritance in Java. Hybrid inheritance is the combination of more than one type of inheritance, which means combination of two or more inheritance is known as hybrid inheritance. In Java, hybrid inheritance is achieved using interfaces and classes because Java does not support multiple inheritance with classes directly. Today we are discussing about final and super keyword in Java. The final keyword in Java is used to restrict modifications in different contexts. Okay. Final variable. Final variable can't be reassigned after it is initialized, which means if we prefix final to a variable, that variable will not be reinitialized. For example, here you can see we are creating a class name is speed control. Here we are declaring and initializing the final variable. Okay, again we are defining a method name is display speed. Here we are reinitializing the final variable. So, according to the definition, we can't reinitialize the final variable. If we are reinitializing the final variable, we will get a compile time error like it can't assign a value to final variable. Okay, let us see. Let us execute the program. Here you can see can't assign a value to final variable speed limit. Okay. And next one is final method. Final method can't be overridden by subclasses, which means if we prefix a method as a final, then that method will not be overridden. For example, here we are creating a parent class. Inside parent class, we are defining a method name is show. We are implementing this method. Inside the child class, we are inherit the parent class, and again we are overriding the parent class method. Whenever you use final as a keyword, that method can't be overridden. So we will get a compile time error like can't override a final method from parent. Okay. And next one is final class. A final class can't be extended or inherited. For example, here we are creating a final class. We are extending the final class in child class. So it will get a compile time error like it can't inherit from final class vehicle. Super keyword. The super keyword is used to access members of a parent class from a subclass, which means super keyword is used to access the parent class members in child class. We can use super keyword anywhere in the method. Okay. Example program. Class name is WhatsApp. Here we are defining a method as send and we are implementing this method. Again we are creating a child class. Child class name is WhatsApp test, which inheriting the parent class. Okay. Again, we are defining a method. Inside this method, we are using the super keyword to call the parent class members. And again, we are printing the statement as by. Inside the main method to execute the program, here we are creating an object for child class. And it calls the overridden method in child class. Here, it comes here. First statement is super.send. So, first it will execute the hi statement, then it will print the bye statement. So, output it returns like hi, bye. Today we are going to discuss about abstraction in Java. Abstraction is one of the core concepts of object-oriented programming in Java, and it is the process of hiding the implementation details from the user and only exposing the essential functionalities, which means it is the process of hiding the internal implementation and showing only functionality to the user. What is abstraction? Abstraction allows you to focus on what an object does and rather than how it does it. Okay. And also it helps to reducing the code complexity and increasing the reusability. In Java, we can achieve abstraction in two ways, using abstract class and using interface. Abstract class. An abstract class is a class that can't be instantiated, and it can have both abstract and concrete methods. And also, it is declared using the abstract keyword, which means abstract class is can't be instantiated, and it allows both abstract methods and concrete methods. This is the syntax for abstract class. Here you can see a class is prefixed with abstract keyword. So this is an abstract class. Inside abstract class we can define abstract methods as well as concrete methods. Abstract methods in Java. An abstract method is a method that is declared but does not have an implementation. Abstract method, which means a method prefixed with abstract keyword and ends with a semicolon, and that method does not having implementation, it is known as abstract method. Here you can see the syntax: abstract, access modifier, return type, and method name, formal arguments. And here you can see it ends with semicolon. So this is abstract method and it doesn't have any implementation. Key points about abstract methods: it is declared inside an abstract class or interface, and it has no body. Now we will discuss real life example of abstraction. Let us assume you are using a TV remote to turn the TV on or off. When you press that power button, the TV turns on or off, and you don't need to know what happens inside the TV or how the circuit works, right? And it hides the internal working from the user, and you just interact with the remote and it performs the required action. And user no need to know what happens inside the TV, how the circuit works, right? Just they know how to operate that remote. That's it. Here you can see the example. Abstract class, which is representing a TV remote. Now according to the definition, abstract class having at least one abstract method. So let us create one abstract method. Method name is press power button. So abstract method ends with semicolon. Now we create one concrete class representing a Samsung TV and which extending the TV remote. Okay, class name is Samsung TV, which is inheriting the parent class, right? So extends parent class. Here child class forcing us to add unimplemented method which is present in parent class. So here we are implementing the abstract method from TV remote. Void. Here we are printing one statement: Samsung TV is turning on. Coming to the main class, public static void main. Here we are creating an object for child class. So it calls the parent class. So it calls the implemented method, which is present in the child class. Yes. Here we can't instantiate the TV remote, which means parent class. Why? Because this parent class is prefixed with abstract keyword. So abstract class can't be instantiated. So here we are creating an object for child class and we are calling the implemented method. So output it returns Samsung TV is turning on. Today we are going to discuss about wrapper classes, and we will try to understand what are wrapper classes, and also we would discuss about why do we need wrapper classes. Okay, wrapper classes. Java provides corresponding classes for each primitive data type known as wrapper classes, and these classes act as wrapper around primitive values and provide additional functionality. And Java provides wrapper classes for each primitive data type. So we know that there are a lot of primitive variable types that we have already discussed about, right? So Boolean, char, byte, short, int, the one which we are used frequently, and long, float, double. The thing is, in Java, there are corresponding classes for each of these primitive types. So these classes are called wrapper classes because they are like a wrapper around this value. So if I take int, the wrapper class is integer, and all the other ones are exactly the same names except char and int. So the wrapper class for char is character, for int is integer, and remaining all are same. Starting letter should be capital. Okay, boolean, boolean, byte, byte, and all are same. Yeah, the question might be, if I have primitive values, why do I really need wrapper classes, right? The thing about wrapper classes is they offer you a lot of additional options. Let's say, why do we need wrapper classes, right? Conversion between strings and primitive types. One more point we should add here. Conversion between strings and primitive types. Yeah, it is used to convert a string to an integer and also convert a string to a boolean as well. Okay. Let's say I would want to create a boolean value from a string, or I would want to create a integer value from a string. You can do that using wrapper classes. And the next one is collection framework capability. Collections like array list, hash map, hash set, etc. only works with object, not primitive data types. Yes, collections can store only objects, not primitives. The other things that wrapper classes provides a number of utility methods, and it is used for parsing, comparing, and converting the values. So let's say I have a float and I would want the integer value of that specific float. So I can use the int value of method. So there are a lot of utility methods like this which is offered by the wrapper class. Okay. And next point is auto boxing and unboxing. Java automatically converts primitive data type to wrapper objects. So let's do an example for auto boxing and unboxing. Yeah, auto boxing, which means it is used to converting a primitive type into an integer object. So here we are declaring a primitive int variable. So int I equals to 10. Okay. And here we are declaring an integer wrapper class object and assign a primitive int value using auto boxing. So integer I equals to num equals to I. Now we are printing these values. Sys.out println I. Now let's execute the code. Here it prints the primitive int value I. This print statement prints the primitive int value, and this print statement prints the integer object value. Okay, let's run the code. Here you can see this one is primitive int value and this one is integer object value. Autocasting can be done in two ways, implicit way and explicit way. We are done in implicit format. Now we do explicit way. Okay, so here again we are declaring primitive int variable. So int a equals to 10, and so here we are declaring an integer wrapper class object and assign a primitive int value using value of method. Okay, so integer I equals to integer dot value of, we are passing the primitive data, so a. Now we are printing values. Sys.out println so here we are printing a value, and again print one more printing statement. Here we are printing I value. So this printing statement prints the primitive int value 10, and this printing statement prints the integer object value 10. Okay, let's execute the code. Here you can see this value is primitive int value and this one is integer object value. Okay, Unboxing is used to convert wrapper object into primitive data type. So unboxing can be done in two ways. One is implicit unboxing and other one is explicit unboxing. Implicit unboxing is nothing but converting wrapper object into primitive data without using any method. Okay, let's do the code. Now we are doing explicit unboxing. So this is the process of converting wrapper object into primitive data type by using value method. Okay. So here we are declares an integer wrapper class object and assign the value integer I equals to. Now you also know how to create wrapper classes. Creating wrapper classes is very simple. It's just like int I equals to 4. Yeah, same way. So there are two ways you can create wrapper classes using constructor and value of. We are creating wrapper classes using constructor. Integer I equals to new integer of 5. Now integer value is created with the value of 5. Now let's say I am creating another integer. Let's say I am creating another integer I1 equals to new integer of 5. Let's say I and I1 have same values, right? This is one way of creating integer. The way of creating integers using value of method. So using value of method, right? Integer dot value of. We are passing 5 as a value. Okay. So these are two ways of creating wrapper classes using constructor and using value of method. Okay. So integer I1 equals to new integer of integer I equals to new integer of 5 and integer I1 equals to new integer of 5. So let's write this code again. So same value I am creating two integers. So now I will do I double equals to I1. If you remember, double equals to does not compares the value, it compares the memory allocation. Okay, so I and I1 they have same value but difference in memory, so it returns false. But again I am creating this. So here I am creating two integer values with the help of value of method. Okay, let's consider this one as I1. Spelling check. Okay. Now here I will do I double equals to I1. So it returns true. Why? Because one of the important things is, just like string classes, all the wrapper classes are also mutable. So that means once a value is assigned to them, you can't change it. What integer value of method does it okay. Why do I need to create another instance of the same value? I would check and reuse if there is an existing object of the integer with the same value. If the same value is already there is no need to create another object. It will store the value in the existing ones. So it returns true. And some of the useful methods in wrapper class, if you want to convert string to integer, then you use value of method. And if you want to convert string to int, then you use parseInt method. If you want to convert integer to string, you use toString method. If you want to convert string to boolean, then you use parseBoolean method. Okay. Now next one is packages in Java. A package is a way to organize related classes and interfaces together to avoid naming conflicts and manage access control. Yeah, which means package is nothing but a folder. It is used to store group of classes, interfaces, and subclasses. So the main advantages of packages is it is used to avoid naming conflicts and also it is used to manage access control. Okay, which means it is used to maintain accessibility of classes and interfaces. So in Java there are two types of packages, built-in packages and next one is user defined package. Okay, coming to built-in packages, Java provides several built-in packages like java.lang, java.util, java.io, java.sql. Java.lang is default package and this is used for utility classes, and java.io is used for input or output operations, and java.sql is used for database connectivity. Let's see the example. Now here I am creating an array list type string. So array list, and array list is a dynamic array that allows adding and removing the elements. So array list string list equals to new array list. Okay, ends with semicolon. And here now we are adding a string Java to the array list. So list dot add, with the help of add method we are adding the string. So that's why using double quotes Java semicolon. Now we are printing the statement sys out println, we are printing the list. So over here you can see it's automatically importing the built-in Java utility package that contains the array list class. Okay, let's run the code. Here you can see the output here. So it returns Java. And next one is user-defined packages. A user-defined package is created by developers to group related classes, which means a package which is defined by the user or programmer. And this is the syntax for user-defined package. Package name. Using import versus fully qualified name. Using import. Yes, it is a keyword is used to import the classes or interfaces referenced in other packages. And also we should use import statement as the first statement in the program. For a program we can write multiple import statements. Okay. In this one you can import java.util.arraylist statement imports the arraylist class. So this allows us to use arraylist string directly without prefixing it with java.util. Okay, and everyone recommended this because it makes code cleaner and more readable without import statement. Yes, instead of importing array list we directly specifying it full path, which means java.util.arraylist. So while we are specifying the full path, so this is fully qualified name. So that's why it is a fully qualified name. Here we are using full path java.util.arraylist. So in this case it will increase the code length. So to avoid this we are using import statement. Okay, and some of the advantages of using packages, it avoids class name conflicts, which means packages is mainly used to avoid naming conflict. Yeah, and also it organizes the classes for better maintainability, and it's control access with access modifier. And next one is reusability. Classes in package can be easily reused in multiple projects. Yes, and also it is used to improve readability and maintainability, and also it is used to achieve security. Okay. Next topic is access modifier. Access modifiers in Java defines the scope and visibility of classes, variables, methods, and constructors. And access modifiers are responsible to change accessibility of members. And this is the figure of access modifier. Coming to public, it is accessible everywhere. So public is accessible within the class, and within the package, and within the package and other package as well, which means subclass, and outside the package. And this is the example for public. So this public class we can access within the class, within the package, and within the package and other packages, and also outside the package. Okay. And next one is protected. It is accessible in the same package and subclass, even in different packages, which means it can be accessible within the package and other packages, and it is not accessible from outside the package without inheritance. Yes, this protected access modifier is not accessible for outside the package without interface concept. Okay. Yeah, here we are creating one class, and we are define one method using protected access modifier. Here we are implementing this method, and again we are creating a child class which is inheriting the parent class. Inside the main method we are creating the child class object, and we are calling the parent class method. It's work cause of inheriting concept. Okay. And next one is default modifier. It is accessible within the same package. So this is an example for default access modifier. And next one is private. Private access modifier only accessible within the same class. As private is a class level access modifier. So private is applicable only for variables, methods and constructors, and it is not accessible from subclasses and other classes even in the same package. And if a member is prefixed with a private access modifier, we can use only inside the class but not outside the class and other packages as well. Here you can see the example. Here I am defining one variable and method with the private access modifier. So this variable and this method can be accessed only inside this class, and we can't access these variables and method outside the class and other package as well. Here you can see some key points. Classes can only be public or default. And next one is methods and variables can use all four access modifiers. Next one is use private access modifier for encapsulation and protected for inheritance, and public for global access. Okay. Today we are going to discuss about typecasting in Java. Typecasting is the process of converting one data type into another. In Java there are two types of typecasting. One is primitive typecasting and another one is object typecasting. Coming to primitive typecasting, again it has two types: implicit typecasting, which is also known as widening typecasting, and next one is explicit typecasting, which is also known as narrowing typecasting. Implicit typecasting. It is mainly used to converting a smaller data type to larger type, and it happens automatically, no data loss, which means while performing widening there is no data loss. Since there is no data loss, compiler will convert smaller range data type to larger range data type implicitly. Here you can see the example. First we declare an integer variable and assign a value to it. Okay, int num equals to 10. I'm assigning value 10 here. Now I'm declare double d equals to num. This line demonstrates implicit typecasting, which means Java automatically converts the int value to a double. Okay. Now I am printing the double value, which includes a decimal point as well. Now I am printing a double value, which includes a decimal point. Start out. And here I am printing d value. Okay. Let's run the code. Here you can see where Java automatically converts int to a double without explicit typecasting, since double has larger storage capacity than int. Okay. So this is known as implicit typecasting. And next one is explicit typecasting, which is also known as narrowing typecasting. So it is used to convert a larger data type to smaller data type. So explicit typecasting, there is a data loss. Since there is a data loss, compiler will not perform implicit typecasting. So we should perform explicit typecasting. Explicit typecasting can be performed with the help of typecast operator. Here you can see the example. Okay. And here we are writing explicit typecasting. So here I am declaring one double variable with a decimal value. D equals to 10 point. Sorry. Now we perform explicit typecasting using int num equals to int specific. Here int d converts the double value to a integer, so it removes the decimal part. Now we are printing the result. Here we are printing the result. Let's see. This is out. Num. So the result we get integer value, which means 10. Right? Let's run the code. Here you can see double value is converting to integer value. And second one is object typecasting. A typecasting in inheritance allows converting objects between parent and child classes, which means to perform object typecasting, inheritance is mandatory, and it allows you to convert objects between parent and child classes. There are two types of object typecasting. One is upcasting and other one is downcasting. Okay, in upcasting, it is the process of converting child class object to the parent class reference, and it happens automatically, and it is used to access only the parent class methods. Here, with the help of upcasting reference, we can access only superclass members, but not subclass members. And also one more point is there, when we perform upcasting, subclass members are hidden. And the main advantage of upcasting is generalization. Generalization means container can store any type of subclass reference. Now let's write the example of upcasting. Yeah. First I create one parent class name is parent. Inside the parent class, here I define one method, void show and I'm implemented this method sysout sysout.println. Here I'm printing the message as this is parent class. Okay. Now I create one child class named as child, which is inheriting the parent class with the help of strings keyword parent. Again I define one method void display. I'm implemented this method sysout.println. Here I'm giving the message in double quotes. This is child class. So inside the main method, now I'm creating a child class object but referencing it with a parent class variable, which means we are doing upcasting here. So first so here I'm creating child class object but referencing it with the parent class variable. Okay, so we are calling a method that is defined in the parent class. So object.show. So it allows parent class method can be accessed here. So it accesses the parent class method. Can be accessed. Okay. Okay. Let's run the code. Here you can see this is parent class method can be accessed here. So let's try to call the child class method as well. Okay. Sorry. Not child class method is this. So here we are calling the child class method. We get error. Even though the actual object is of child type, it is referenced as a parent. Okay, so only parent class methods are accessible here. If you wanted to access the child class method, then you perform downcasting. Okay. And next one is downcasting, which is also known as explicit typecasting. So it converts a parent class reference back to a child class reference, which means the process of converting parent class reference to child class reference is known as downcasting, and it needs explicit casting and parent reference. Means downcasting can be done only explicitly with the help of typecast operator. Okay, used when accessing child specific methods after upcasting. Yeah, which is nothing but to perform downcasting, upcasting is mandatory, and with the help of downcasted reference we can access both parent class members as well as subclass members. Okay, let us write the code of downcasting. Okay, here I am creating one parent class and define one method void show, and I am implemented this method. Sorry, start out, and I am giving the message this is the parent class. Again I am create one child class named as child, which extends the parent class. Why? Which means why? Because while doing typecasting, inheritance concept is mandatory. So it inheriting the parent class. Again, I am define one method void display. I am implemented this method dot println. Here I am giving the message this is child class. So inside the main class, I am doing upcasting. So I am creating a child class object but referencing it with the parent class variable. So parent obj equals to new child. Okay. And now I'm doing downcasting. So now we are converting the parent class reference to the child class reference. So child c equals to child obj. So explicit, we are doing explicit casting. So parent class reference converting to child class reference. Converts parent to child. So now we can access child class methods. C dot display. Okay. So it allows we can access both child class and superclass members. You can call parent class member as well. Okay. Let's run the code. here you can see this is child class. Why? Because we are calling first this method, and next this is parent class, and we are calling second as parent class method. So it returns the output this way. Okay.